In this video, we'll do a very quick review of the dot product of two vectors. The dot product is an operation that takes two vectors, a vector times a vector. The operation we call the dot product, and the resulting quantity that we get from multiplying these two vectors together, if you like, is a new quantity called their dot product or scalar product, and that result is a scalar. That means a real number in this context. So if some number comes out, two vectors go in, and a number comes out. Now, how do we do that? Well, if you tell me the components of the vectors, so I'm going to take u to be the vector u1, u2, and u3, and I take v to be the vector v1, v2, and v3, the component form of the dot product, meaning the formula for it, in terms of the components of those two vectors, is just to multiply corresponding components together and sum the results. So I'm going to take u1 times v1, u2 times v2, and u3 times v3, sum them all up, and that quantity is what we call the dot product u dot v. It's an easy to do calculation, but what does it mean geometrically? So we should review the geometric form of the dot product. And I'm going to draw my two vectors u and v generically. There is some angle between them, and notice that that angle, there's really two angles between them. There's this small angle, which I'm calling theta, and there's a much bigger angle that I get from going around the other way. So when I talk about the angle between them, I'm talking about the angle between 0 and 180 degrees, or pi radians. And we'll call that theta. And the dot product, it turns out to be that the dot product of two vectors is the lengths of those two vectors multiplied together times the cosine of the angle between them. There is a proof that shows what is in this box here agrees with what's in this box here. In other words, that the calculation you're doing here in terms of components actually agrees with this geometric interpretation as the product of lengths times the cosine of the angle. That proof requires the law of cosines from trigonometry. It is a very straightforward calculation, and I encourage you to review that. You can find it in any standard calculus textbook, but we won't do that here because we're just doing a quick review. If I just plot the cosine of theta on the horizontal axis here, I have my angle theta. It goes up to pi, so up to 180 degrees, and on the y-axis I'm plotting cosine of theta somewhat crudely. At pi over 2 at 90 degrees it's 0, and it starts at 1 and ends at -1 here. So if we just think about some situations here, if I take the dot product of two vectors and I get a positive number, well, why would that happen geometrically? The lengths are positive, assuming my vectors are non-zero vectors. Those are positive numbers there. So it must be because the cosine of theta was positive if this product is going to be positive. And so if I see a dot product that's positive, I can immediately conclude that I'm in the first quadrant, that my angle is between 0 and pi over 2, and that my angle is in fact acute. If I, on the other hand, take the dot product and I get a negative number, why would this expression here be negative? It must be because the cosine is negative, and that occurs when my angle is in the second quadrant between pi over 2 and pi. In this case, the angle is obtuse. Now, of course, there's the third situation where my two vectors, say, are non-zero vectors, and I get 0 for their dot product. That would occur because the angle between them was pi over 2. And in this situation, we say that the angle, or the vectors, are orthogonal to each other, that they're at right angles to each other, like we see in this picture here. So the dot product sign tells us about the size of the angle between the two vectors. Let's do a quick calculation. I'm going to take u to be the vector 1, 0, minus 1. I'll take v to be the vector minus 2, 2, and 2, and w to be the vector 1, 0, and 1. Let's focus on the first two vectors. Let's take their dot product, u dot v. I multiply corresponding components together, so I'm going to take minus 2 times 1, plus 0 times 2, plus 2 times minus 1, sum the results together, and I get minus 4. The fact that that is negative immediately tells me that those two vectors form an obtuse angle, something bigger than 90 degrees. If I really wanted to find that angle explicitly, get its an actual measurement for the angle itself, I could take my formula for the dot product here and solve for the cosine of the angle. And if I do that, cosine of theta is the dot product divided by the lengths of the vectors. I've already calculated the dot product. It's -4, so let's find the length of each vector. You sum up the squares of each component, so I have 1 squared plus 0 squared plus 1 squared, and take the square root to get a length, and you have square root of 2. For v, we'll sum up the squares here. It's going to be -2 squared, so 4 plus 4 plus 4 when I square everything up, and I have square root of 12. And then form the appropriate ratio. It's going to be -4, the dot product, divide by the lengths here, and you get some number here, and that is the cosine, not the angle, but the cosine of the angle between the two vectors. And if you want to get an estimate for that angle, you can now go to a calculator and find the angle theta is the arc cosine, inverse cosine of this ugly number that we just calculated, and I did this ahead of time, and in degrees I got a value of about 144 degrees for that angle, which is certainly bigger than 90 degrees. Finally, let's take u with the third vector w and take their dot product. I take corresponding components, 1 times 1 plus 0 times 0 plus -1 times 1, and because the signs here cancel out the 1 and -1 exactly, I get 0 for the dot product, and I can immediately conclude that these two vectors are orthogonal, that the angle between them is 90 degrees.